Okay, so I try to make up for the few minutes that I was late last time. Hello. We just pretend the stream didn't start yet. It's an AI, yes. It's on time. That's impossible. Hey everyone, I will greet you. I will start the stream on exactly 7, and until then, do I spoil? No. I mean, you saw the cover, didn't you? So I have. Should we just start? Should we just start? Okay. Okay. Let's pretend. Let's just start. Okay. Here's. Hello everyone. Welcome to the stream. Hello Tech, hello Adam, hello Dodge Taurus, hello Johnny, hello Evolix. Why is your name different color? I'm confused. Hey Jordi. So, so today, what is happening? What is happening with my chat display there? What? It's broken now. Do you see? Do you see? Do you see this here? Why is this broken? What? What's happening there? Joe Unknown, hello. Oh no. Yeah. Oops. Oh no. I don't know what happened. Ah. Hey Sniff. M40K. What happened? What happened to the... Okay, this is... Oh no. Now everything is broken. Is this some kind... Is this something has... I removed the custom CSS. Okay. Okay, and this is how it looks. The doxing one. Okay. So apparently it's broken. Dwukropek. Okay. Oh, let's find out. OBS YouTube chat CSS generator. Okay. Is there an update for that? Maybe there was an update that I missed. Okay, I will just copy that. No, I didn't create it. I used Dupont. I used a generator. Okay. But I need the background to be... I need it to be semi-transparent like that. I hate the font. What font is that? I need a new font. I like that one. That looks modern. Caroy's Gothic, whatever. Oh no. What is this? Aleph? Oh no. it's quite easy to read. Okay, font size 18. We don't, oh, okay, make it 19, 20, okay. But why is this like super chat? Okay, that's too huge. Okay, here we go. Oh. What is this again? It's broken again. Okay. YouTube chat is broken today. I can do nothing about that. I might turn it off at some point. Okay. It happens again. What? No. Is this some kind of hack? Sniff. Now it happens after your comment. I have no clue what happened. Uh-oh. Oh no. Ah. Yeah. Okay, you know what? Screw this. I don't need this. I don't need this. I turn this off and the chat will be lost. Oh. So I can't dox myself today. If I dox myself and edit it, the chat will be gone. And we can't do longer than 6 hours. Oh no. There's no. Look at this. I don't know what. Is there a plugin that will. It's somehow it needs a refresh or something. I don't know. It's strange. It's strange. Animation, I should turn off all the stuff. No, it starts again. No, I can't use the chat. Okay. I have no clue what's happening here. Unless I will. Oh, wait. I can do the following. I will remove that. Whoop. And shift it down like that to clip the field there. And let's see if it also happens with. Oh, there's the bar, the scroll bar. Here we go. And the fondue window. Here we go. Here we go. It's it's normal now without any. Yeah. Okay. I'm sorry. You are here to see. Oh, I need to change that scene as well, huh? Whoop. Whoop. Yeah, I have. Okay, so yeah, since last time, oh, what happened last time? Last time we did this abomination of trying to wire up a ton of wires with this ADC that supports 100 megasamples. And on Thursday, I sat down and it took me a whole day to do this, to like design the footprints and so on for, I made everything nice and dandy, and I will show you the board anyways. Let me disconnect that. And it arrived today actually, but the stupid connectors to connect here with that here, with the waveform generator, they didn't arrive because we have postal service strikes. So I'm waiting. They should have arrived already on Friday. They didn't, so it's a bummer. We have like to solder. I have like pin header here, a spot for pin header where we can connect the input plus minus. So there is the ADC. I tried. Okay. I tried to keep the tracks like similar length and not much happening there. So these are the 8 bits, digitized 8 bits. Then we have some capacitors and so on. I didn't do any input filtering whatsoever. This is something that, except for capacitor on the input. Then there is a voltage divider for the IOs, and this is currently set just to 3.3 volts. Then we have some 0 ohm bridges to connect the second input, which is wired up to the ADC, but the second input parallel output isn't used yet, because this bank works at 1.8 volts. What is this on my finger here? Works on 1.8 volts, so I would have to change everything to 1.8 volts. And this is like clock divider, output select, format, and so on. I pre-configured it to meaningful values, and I could always change it. So I could either control it via a pin, or it's hard-coded to be high or low right now. So there are a few options for that. There is an option for an external trigger. On the back side, there is nothing there. So this is that. And yeah, I got the boards today. I ordered them from Isla, express shipping. I paid like extra express shipping for it to arrive today, since I ordered them after 6 o'clock in the evening on Thursday, and they arrived today, so at 12 o'clock. So this was okay. Unfortunately, not all the parts, like the connectors, are here. It's working with, or I didn't try it yet. I just checked if there is a short, and there is none. So I can connect this, and this is our old sketch that's running, since I can see it's counting up. But we have to configure the pins. I have no clue what's happening there with the pins. I should rather not connect it. So let's just configure the FPGA first before we connect it and do terrible stuff. Yeah, we might even like short stuff there if I'm not careful, because the pins changed a little bit. I did this whole ordeal on KiCad, so we have, oh, by the way, we had the wrong configuration last time a little bit. Yeah, there is like, I think that was even we should use two's complement. The other one is gray code or something, and you need some decoding for gray codes, and that's why the signal looked so odd, I think. However, where is my KiCad stuff here? Okay, here is the schematic. Let me turn it on. Screen capture is on. Boop. Ui, it's all small. Okay, so this is how it looks like. Some decoupling, input, output, not connected stuff. Then this is my selection between whatever. I mean, there are like sortable pads for that in KiCad, but I wanted to have it like surface mount. So if I populate it in a fab, it's easier. Yeah, some connectors that... Hello, Daniel. Some connectors, and there's like this configuration for the coaxial stuff as well, but that's not for now. Oh, I didn't talk about the food yet. Let me present the food selection for today. I was really lucky that currently the fondue is discounted in one of the discounters, so it's cheap and even cheaper there, $2.50 per pack. And this food is that the cheese is good until August or something. So I could buy it all off, like 20 packets for that. But I want to conserve some money. We have cheese fondue here, then bread, the good old good crust. No, not vegan. That was terrible one time we tried. Okay, so with good crust, sourdough. Then we have a small selection of healthier stuff like olives, tomatoes, and pickle. Then we have some sweets for later, like milk chocolate cookie stuff. And these are my favorites. This is like yeah, they have some core, a flux core, if you know what I mean. And we can turn that on, that fondue, and I will add some flux later. So we have some. Yeah, oh yeah. And we have some Aldi brand, no name drink, like energy drink, and some lemon tasty flux core. Yeah. So let's take a look at our goals. So extra designed a board. Yeah, that happened. I mean, make a display. Board is designed and it's even made and everything. So that is done. Then we have yeah, we are not sure. Okay, so solder IC connects. I don't know if okay, get samples. Let's this is unknown if this works, the connect. Samples, make a display, yeah, trigger warning. And what else do we set? Scale, yeah. Oh yeah, I didn't even plan to have any input. Yeah, we can solder a header. I have all my IOs are available. Pink LED. Oh no. Oh no, pink LED is missing. Okay, let's check. Let's check the connections, because I forgot everything. I mean, the board has even like, let me take a look at the board. Where's the board? Ah, here. So we set everything sync and TR. What is? Oh, that's trigger. Trigger signal. Trigger, and what is sync? Oh, sync is not needed really. Sync. Let's take a look at our code. Bop, 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 bop. Oh yeah, let me set all the configurations here. So span, what is span again? Span, not span, is 31 now. Then we have formats. Format is 49. Then we have outcell. Outcell is 48. So was a little bit. What else do we have? Diff. Is now 63. They are really random, huh? And SHDN, which is one of the more important. HDN. HDN is 32. And then we have, why did I use 0 ohm resistors to pull it high? It would be easier to use like 10K, and then I can short things to change it. Okay, whatever. Trigger and sync. We need trigger. Or let's call it trig, come. And sync. Okay, trigger will be at 76, and sync is 77. Then we need our ADC data. Oh, what is, oh no, that's not shown here, huh? Okay. Yeah, I need to find out from the data sheet, not the data sheet, from the schematics. Okay. Oh, yeah, that's easy. 28, 27, 26, 25. Okay. 28, 7, 6, 5, and then we have 39, 36, 37, 39, 36, 37, and then 38, 38. Oh, the clocks. 30 and 29. Wait, clock positive is 30, 29. What is Dora? Heh. Oh yeah, that's the output. On the right side, these are outputs. STTS that? I didn't hear that with the replace the mic LEDs. Test it, test it. Okay, that's output CPC. Okay, yeah, whatever. CMA. Yeah, that's everything is going out here. Okay. We might need a few more inputs here. Quote. I can't hear anything. It's dead. Oh, here we go. There is only boredom if you protect your excitement. What? Huh? That's contradicting. Yeah, let's compile it. I mean, oops, I did it twice. Oops, huh? What is... Yeah, I see. I try to find out what is 63. It's diff. And what is the other? Oh, 36. Yeah, no. No, thank you. Okay, can't find. These are the ones that we have to add as HDN, trick, and sync in top. Output ADC, HDN, output trick, oops, output, oh no, that's an input. Input and ADC, DC sync. I have no clue, oops, if I need the sync or not, or what's the issue there. Okay, it's completed. Let's try uploading it. Where's the uploader? Programmer. Okay, can set it on higher and higher. Okay, this is running. Let me plug it in and see what happens. And we should do, we should try also HDMI if everything works. Okay. I don't know. I don't know. Should I hot plug the screen? You like it when I do that. Oh no. Should I? No, let's not try to destroy it now. Okay. Okay, there is okay. Oh yeah, it's two's complement, so should be negative. So we need to change a few things. Oh, this is I see it already working. Oh no, this would be awesome. It seems like he lives next to a shop. Okay, cheese is smelting. Cheese is smelting. I will add some flux soon. And the lid doesn't close that well. Okay. So ADC data. So we are recording at when the first row of when display is running. We are recording. We should do this at the last row when it's not displayed. We are recording it with added and ADC data. We should use it as assigned value. Is there like, wasn't it like signed? And we should add 7, that's like 9. Or 10 even, if we have a sign. For 20, I don't think that this will work. Yeah, no driver. Input is unused. Oh, it might have even worked. So apparently in Verilog, you have to be very particular about signed, unsigned. Oh, okay, it uploaded. Now let me touch the input. Oh no. Shoot. It doesn't look like it's like, it looks like a sign error. Yeah, let's try and do it a different way. Huh. Okay, let's do it like that. We have 8 bits. The flashy line, it's like, oh yeah, when we are recording, I think this was happening because we are recording the first row. Let's do the following. Let's do a wire 8 bits wide, so 70. We shouldn't oh, wire signed. Or value assign value, or let's say ADC ADCA, like that, because we have two channels. Okay, here equals ADC data. Let's see if that changes anything, because we might mess with the signs. Let's check out if that changes anything. Uploading, and oh, that's slow uploading. Okay. Nope. It's still yeah, you see a value there. I think it might be also just negative. Negative 25. Oh, positive. Wait. Okay, I need to stir now and add some flux. Flux added. Ah, here we go. Yeah, something is strange. Okay, I turn it down a little bit and let it soak for a few minutes before we can start. Okay, let me change it. Let's do it like that. Let's not care about signed or unsigned or whatever. Let's do just that plus 128. No, yeah. 128 and minus 128 here. Oh. Okay, let's see how it's clipped. Oh, yes. Okay, that's better now. Just ignore anything. So when I touch it, we get some. Yeah. Yeah. Why is this so strange? Okay. Okay, here you go. Here you go. Shippable, yeah, it's shippable. Okay, Now we can try waveform generator and connect it to, we can either solder on some stuff here. Yeah, you missed everything. Look at this. We get readings. What is the frequency set to? It's quite, isn't it quite high? Okay, so we connect to ground here. Maybe, I don't know. Should we? Yeah, it's working now already. You are mean. Do I have some kind of pins that would be better to connect there? Okay, wave gen on. Okay, it's clipped. It's clipped. Offset. Oh yeah, the offset is set to millivolts. Yeah, I need a better connector. Let me change the offset. Yeah. 1.25 peak to peak, so we need to set it to 6 volts. 600 millivolts. Doesn't change anything here. Okay, let me connect. We might need to connect also the ground and do a single. Oh. Okay, this is with ground connected. There is still a bias that clips the input. Whoa. This is at what is the current frequency? 27 megahertz. Okay, apparently we get what we want. Now we should go to up to 100 megasamples, solder a header, and oh, let's check off stuff from our list, shall we? So, get samples is done. Connect. Trigger. Set scale. Now there are a few things that we can do. We have HDMI. We can add HDMI here to the main list even, because yeah, why not? HDMI, and we need also 100 megabits. That's like a mega sample. Okay, because we are not at 100 now. Connect, we are not completely done yet because we need to like get the single-ended input set up properly, and I might not have done it yet. Hello Arduino zone. Okay, so let's disconnect it and solder on, I don't know, a female header. Should we use a male or a female header in here? I think we, yeah, let's let's maybe use, yeah, I mean, I have those clamps here, but I will use, yeah, I will use a female one. That should be easy. Do I even have a 4-pin short one here? Gender neutral. Oh, jokester, you. Okay. Let me file that flat. Okay. Do you want to see the soldering, or should I just do it and be done in a few seconds? Because I think that's easier. Ah. Da, 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 da. Let me clone that. Duplicate. And change that up here. That's the face cam. Oh, wrong. Fondue cam. And where's the face cam? Face cam goes up. Like that. Okay. And this title goes here. Okay. I will do a quick solder here, a quick solder job. Okay, good enough. Okay. Header soldered on. And now we can connect maybe this somehow directly. Yeah. This should be ground or negative. Wait, we have a differential thingy going on here. So we can use a negative here and the positive here. I don't know what that does. Ah. Oh yeah, negative was dangling, so that's why it might have been clipped. Now everything, now it should be, no, it's not grounded. Should. Okay, so I will try the single-ended configuration here, because it seems like there are some glitches as well. I don't know why they're happening, but so far, so good. Okay, fondue. It's time for fondue. Oops. Huh? How did the bread land there? They drop some bread in there. Everything USB there. I don't think, oh, that's too, the bread is too fresh. It's very soft. It still needs a little bit of heating. The camera is not pointing at the right spot here. Here we go. Oh yeah. Oh yeah, give me the good crust here. That's a huge piece. Should be careful to not drip it on the 12K scope here. I mean, I can replace it now with this DIY scope. Wait a minute. Maybe the signal is like too high, the voltage. Yes! We have 1 volt. 1 volt. And why is the shift so... Is it? Wait, amplitude. Now it's clipped there. It doesn't look like we are getting the full range though. Because that should be, there is a bias. There is a way to remove that bias with a single-ended. Yeah, there's no, the offset doesn't do, on the scope doesn't do anything because we have like a capacitor in between. What do you mean range? What kind of range are you asking for? I think it could be like, let me check. Oh wait, wrong. Yeah, let me check that. I prepared everything, including, there is even a pin that says if we are out of range. There is an indicator. Okay. 1.5, very wide input common mode voltage. Okay, so we should be able to use an amplitude of 0.7 volt. Oh, this is so tasty. I'm sorry you're watching me eating right now. I give you some heads cheese input. That's good. Let me change the frequency for, let's increase the frequency. This is 500 kilohertz. That's like 2.9 megahertz or what? What is the, yeah, you can't really tell. It's like 2.8 megahertz. But we should be able to see, yeah, 5.8. We should be able to see, not 20, oh, wait. The limit is 20 megahertz? Oh, now we are Nyquist frequency. Okay. This is 13.5 megahertz. It looks like there is like, might be a sampling division or something, because we should see, oh no, it could be right. It's half the frequency. At 7.5 we should see let me put 7 point, yeah. So this is 4 samples per clock. Or, yeah. Should we change the clock now? Oh, this is so good. Damn. I can stop. Okay, one more. One more. Okay, two more. Two more. Maybe something veggie-like. The pickle. Okay, great. Now, let's crank it up to the full bridge rectifier. Full swing. Hey, Sienna. You're watching this new ADC board sampling at currently 27 megahertz. No trigger yet. But we'll improve that. Yeah, and there is like the input isn't that great. Oops. Where's, oh, come on, here. Okay. So we have, it's a little bit clipped. We are missing some input filtering here. Okay. So currently I have only this capacitor and nothing else. So there is an op amp. Oh yeah, in minus should be tied to ground. This is the single-ended AC coupled input drive, single-ended differential clock input. I have that. Okay, so this is what we have right now. This is on the board. There is nothing connected here. There is no resistor, no nothing. We can add this 100 nanofarad cap. Oh yeah, this is connected and this is connected. So both are 100 nanofarads. This one is missing. We have just connected ground to that. This is single-ended differential clock input. Yeah. What kind of Schottky is that? It's like, oh. Clock input, interesting. Transformer coupled input drive for input frequencies beyond Nyquist. Then we have that here. Up to Nyquist. We can try that here. So there is, we would need to replace that here, because this is now AC coupled. I can replace it by a 0 ohms resistor and do all this filtering outside on an extra board. I have this transformer here. The center isn't connected. This is grounded. But unfortunately, oh yeah, I have the ground there. I have everything. So I have on my small connector here, since I didn't know how to do the filtering yet, or I didn't want to like populate every configuration, I have input, output, you can see ground and CMA. So that's what we need. We have CM, yeah. CM, is this A? Yeah, that's CM, yeah, whatever. CM input, 36.5 ohms. And that transformer. We can solder that. So input circuit could be okay. Let me take a look at the transformer. Or should we do software first? Or remove the 100 nanofarad capacitor and just connect it. Okay, we can try that. Let's start replacing. So this is like the AC coupled thing, because I don't have that driver. And this is basically centering. Yeah, this is like just the minus, wait. This one is missing. I can try that, adding that cap first. Okay, let's do that. There is a spot for that. I can show that. Here there is C2, which should be, yeah, this should be that. Let me check in the schematic. Resistor in A minus C2. Yeah, that's that. Okay. Let's try that. I will solder that on quickly. Shouldn't be that hard. And be back in a wait. Can't we stream from all the sources? I have so many encoders and cameras. I can connect to my camera here. Okay. What is this? Trash. Okay. Okay. Hey, I love Scotch. Thank you very much. The ADC is only as good as the front end. Yeah, that's true. Super chat. Okay, I turn on the microscope. I hope that works. Doesn't work. Come on. Oh, the HDMI wasn't plugged in properly. Here we go. Ha! Yeah. Bad light source. B CMANA C2. Okay, here we go. A little bit of flux. I do it with the... I have a ton of caps flying around this place, so I can just take one from the table. I hope it's connected, I don't know. C2. Okay, it won't be centered. It will be AC coupled, so it will be terrible. But we might see something. I don't know what. So it's AC coupling. AC coupling is always terrible. That's like, yeah. Yikes. Oh yeah, offset. Let me set that offset to 0. No. No. Oh. Yeah. Okay, now I also connected the ground, and that looks like... That looks legit. The input. Still we should try to do the transformer. Transformer coupled input. Okay, let me check that. Hey, Christopher. Okay. So, yeah, that was that. I just connected input. So our current configuration, I can do paint and... Okay, let's paint what we have now. We have our input looks like that. We have... That's plus, minus, and this is CM. And we have basically CM is now grounded or decoupled, and we have minus is also decoupled, but it's also connected to the in minus, which should be ground. So there is like some kind of, oh, and we have plus is also like in plus. This is our, and I can now try removing that cap because this doesn't matter, and just add a 0 ohms resistor here. So this is our IC. And we should basically get closer and closer to this configuration here. There is no cap here, we can remove it, but yeah, we must put this somehow on extra board. Okay, let's see if we can switch that so we don't have this bias. Switch that by 0 ohms. Did it turn off again? What? Shit. Okay. So where are we? B, A. This is the cap. I need 0 ohms. I think this is 0 ohms. Oh, I have 0 ohms on the, even on my bench here. Ouch. Oh, accident counter plus plus. Just burned my fingers here. Ah! Yeah, I need more. Oh shit, ouch. I burnt my fingers with the... Nah, this is like oscilloscope. This is not the other stuff. Shit. Ow. Ah. Yeah. So apparently tweezers seem to get hot as well. Who could thought? Who could think? Who? I am not capable of speaking today. Now you just. This is like this is low temp paste on that. I don't want to mix right now. I don't want to mix that for now. Okay. Clean that up. Here we go. Okay, 0 ohms. Let's check. Mike, what? I do love this. How to how to do it. How to do it not, maybe. Okay. Oh. Okay. Oh, interesting. Now I see. Now I see it's more pointy towards. That's like more pointy the higher the value. So the input cap, look, do you see that? The input cap actually is seems to be important. Okay, we need a proper, either we scale it. There, yeah, oh, minus, okay, yeah. Nah. Okay, either we do the proper input or we can scale it, but with 8 bits we should not like use correction or whatever. We should just do the circuit. So let's do the circuits. Here we go. We should do this one because it's way easier. Now let's see if I have 36.5 ohms. Ah, 36. Oh, yeah, let's do. Oh no, 39. No, I don't have. Oh no. How do I do that? 36. We can do 70 stack 275 ohms resistors. Yeah. We can just take 275 ohm resistors and put them on top of each other. It will be more or less. 37.5. It says 36 here. Yeah, it will be set 37 if I do, but I mean it's just for a bias. Let me check. I have a ton of chip resistors here. 70. Oh, I have plenty of 75 ohm resistors. Oh, these might be even like 1%, so I rather take these here. Yeah. So let me take a look in this stash. This is only like half of the spools that I have. 150. That's capacitor. What is that? Nobody knows. Let me check that under the microscope. 7.71 ohms or something. This is yeah, there is a writing, so what is this? So 330? Yes. Oh, come on. That's 270. That's LEDs. 4.7. I doubt that I have exactly that value here. 300. 10 ohms. That's henries. Nanofarads. 33K. 1 ohm. We can, we can build it from 1 ohm resistors. They should be precise, though. Yeah, that's capacitance. Okay, nice. Let's do 75 times 2. And where is this component, this transformer component that I got here? Okay, so we have, this is the component from the datasheet, quite expensive. I think I paid $5 or something for these two. So mini circuits, ADT1, this is the small transformer. So we will grab that. We'll grab that. Oh, interesting. Interesting thought. Combining the two channels to get 200 megahertz. Actually, I could. Huh. We control the clock. Did you see that possibility in the data sheet? I mean, there is like some stuff that we can configure. Like, did it say it in the beginning somewhere? Data outputs are available through a dual parallel CMOS compatible output data bus that can be configured as a single multiplexed parallel CMOS bus. Okay, that's, we can put everything on one bus. Dual CMOS or single multiplex CMOS. but then we have to configure it. I don't think we can change that. Max channel, select, no, it doesn't say anything. Wait. Power management. Quote. Okay. Multiplex data. Okay. Multiplex data output on channel A. First followed by data default channel. But how is multiplexed output timing? Oh, you're right. Look at that. Oh, we have like rising and but we need to sample at sampling happens always at the same rate and there is only one clock. So unfortunately we can, oh, this is so cool. We can use the same bus if we would configure it, because there is no different clock. There is only one clock here. So we can't clock it at a different time. Sampling happens always at the same time. So 200 megahertz doesn't work, but I'm wondering, output select. Let me check that. Select, serial port select, outcell, data output mode. Outcell, dual bus, 0. Channel A data bus. But what selects the, I think default could be like on the first bus. So we can get both channels. I don't need all that second bank. We can use on rising and sinking edge one bus. Oh, that's cool. Okay. Yeah, that's a good thing to learn here, the dual bus. I knew there was like, it was confusing a little bit, but it seems, yeah, we don't need all that trash here anymore. Let's just get rid of that because we have all the control. I mean, working with a microcontroller would be more difficult, but since we control the clock and we can do whatever we like, that could be working. Okay, nice. Oops. Nope. Let's, okay. Let's check out the transformer now. We should be able to transform stuff. Oh, this is cute. This is cute. That's a small toroidal. Let's put it under the microscope. Here's the microscope. Here, boop, up. And see what happens there. Okay. So this is the small transformer. Yeah. Sweet. Okay. This center tab is ignored. This is not connected anyways. This should be center, yeah. It's probably center. Okay, cool. Oh, wait. Hey, Seth. Okay, so this is the small thingy. Now, I will put it on a small copper board that we can plug in to the header that we prepared. Oh, sweet. Wait. This is only single-sided. Oh, but it doesn't matter. We don't need dual-sided stuff. Let me check. If I can find anything that is more suitable for that. Yep. We can put it on a single-sided. Yeah, that would work. That could also work with a dip socket or something. Dip socket. I have plenty of copper boards. Yeah, I think I will use just this one here. So this will be good enough. I will solder it like that. I think the center tab is disconnected, so I will just solder that on now. And we will add a header. Let me check the schematic. Let me check the schematic here. Wait, where is it? Here, okay. So this is the output. This is the input. CM, okay. So we need a little bit space between the connector and then we will just ground everything. Okay, that's all right. So let's add all this stuff. How do I? We have in A, in minus ground, and CMA. Unfortunately, it's like a little bit flipped here. So if we take a look at the input of that, it didn't line up properly on the board, and I didn't want to use wires for that, so I changed the order to be like that. So let me just add a 4-pin header here to our board. Can I zoom out? This is the most I can zoom out. What? No way. Okay. Okay, let's sort out the header first. I can't put you higher. I'm sorry. I try. Okay, here we go. Okay. So you have a little bit more. Nope. Still. Okay. This is the best I can do right now, sorry. Oh, my extractor. Oops. Come on. So what are you people up to nowadays? By the way, the cat, I mean, I was maybe talking about it, has a tapeworm, unfortunately. So we are not letting it inside the house because I hope you don't eat. Yeah, the tapeworm drops off some segments, and now we try to treat it. We talk to the owners, and they keeping the cat outside all the time, and that's the type of. Oh, sorry, Seth. -20 Friday. What? What? Okay. Okay, let me disconnect that and. Hey, Max. People are joining late. Okay, the stream is always at 7 o'clock, so it should be like Central European time. It should be all right. Like to. Okay, so unfortunately we don't have that connector because postal service is on strikes, and we can plug that in now. So I now know where to put everything. CMA. Now we have this transformer. And okay, and that should be somewhere here, and we need oh, this is like totally out of focus for you. Maybe I can use that. Oh yeah, I can do this. Okay. Okay, what do we need? Let me take a look at the sheet again. And I need to jump across. Okay, we need Okay, CM minus is connected to ground with that. That's done. We have the two resistors. So 75. We need to connect two 75 ohm resistors. Yeah, that's the good ones. Because we need like something around 35. So it will be, the precision will increase if we put two of the resistors in parallel. Okay, let's not talk about the cat problems. Yeah, but we hope that we can cure that quickly with some typical stuff. And I identified the type of tapeworm it is. And it's actually... Okay, so we need CMA. So let's... Wait. Let's shift it. How do we shift that? Yeah, PCM. Okay. CM. Both go to CM. Other than that, it's just connected. Center tab. Okay. They have the center tab at the inputs. So this way around. Okay. How do I... How do I do that? Okay, let's do that. I will solder it on here. And then I will then add some wires later. HDMI key. Okay. Okay, so transformer should be soldered, just fixed in place. Now we need to add some stuff. So I will add the resistors here. Wait. I will add the resistors. I need to put two on top of each other, but I also need... let's take a leg for that. Or... Okay, in A, I hope I think this, the orientation doesn't matter really, which way around. Yeah, let me get the clipping. There is nothing connected, so I can use that. Okay, so this is plus, so we need to bend it here. Okay. Come on. Is it too far bent? By the way, we will stop doing ADCs on this stream. Next week will be something fresh. Like I expect boards, LED boards, and we continue the magnet project since it was a lot of fun. Magnet LED stuff. I ordered the boards on Sunday, I think. So they're in production already. Or was it Friday? I am not sure. Or Saturday. They're in production already and they should be shipped this week. And that takes probably, I hope the strikes end quite soon in Germany. We should have that by next week. Because I didn't get any letters currently. Nothing. No. Oh, that's a transformer. It's a small toroidal transformer. Now we need the 30 whatever ohms resistance here. This will be okay. Now I need to really, I might change the tip of my soldering iron to something more precise, huh? I need to rotate that. And demonetized. Oh, foo. Yeah. Oh, if any one of you has connections to foundries in Europe or whatever, I want to get on board. and do freelancing and contracting work or whatever. For whatever you need me, I will take the job. I'm a little bit tired of. Yeah. Interestingly, they recommended up to, oh no, it's flipped now. Should I care? We need to put 2 in parallel because I don't have the resistor value. I should order it. I mean, I ordered from Mauser anyways, and I knew what components I might need. Yeah. By the way, did you watch the Dave Jones video on the small RISC-V, cheap S RISC-V? I ordered a few of those. We will do a project with that one. Curious how that works. Ah. Yeah, I don't really want a corporate job. And because I think the times are over with the way that worked in the past. And showing 9 to 5, showing up at some place 9 to 5, and oh no, now it's like I need to put them next to each other. This is so difficult because I have no reach there. Okay. Oh shoot. Okay, they're stacked. Okay, I got this. We can check the resistance in a second. And now, a happy accident, yes. And now we can bridge that 3D resistor. Now this is a 3D 0 ohms resistor now. Get that. So I think like RISC-V is here to stay. Is here to stay, and it is like a gold rush right now. Embedded world is already taken over by that. And oh shit. Yeah, okay. That might work. Oh no, you can see. Is this sharp? Oh no! Surgical. Okay. Ah, here we go. I might want to connect the other ones first. Okay. One more over here. I might just... Nah. I will add this from here. Ah, it's so hot in here. Ah! It fell through the hole. Okay, I got it. Ah, I must get rid of my jacket. It's too warm. Okay, much better. Ah! That worked. Yeah, I might even have like 75 ohm through hole resistors. Okay, this is a 3D resistor again. And now we need to bridge over. Bridge over there. Yeah. Yeah. Where did it go? The cutting. Oh, it fell through the hole again. Okay. So my 3D puzzle. Spock would be proud. 3D chess. Ah! We will check the resistance afterwards, okay? No worries with the 3D resistors. It's a mess right now, but I leave it like that. Okay, let's solder that mess. Yeah, resistance is futile. Good one. Okay, so this is the first part of the circuit. Now we need the input, and then we can also connect the ground. I think I will leave the ground over here. We like solder that like that. So this is the ground. I will put it here so I can grab it. Yeah. I might even, yeah, I can grab it and bend it and do whatever I like with that. And now we need an input. Wait. Oh, we need to ground that one here. On which side? Yeah, this is the side. in a plus. This side will be capacitor and this side will be ground. Oh shoot, it's too short. Oh no! This is too short. Need to replace it. That's in the front, the 100 megahertz front front end here. Or 100 mega sample. It's like only 25 megahertz. It's up to Nyquist, it says. Wait, I don't need to use like a small ceramic cap. I can use a true hole cap here. Yes, that's good. That's good. Okay. That's the input. Oops. Here, this is my capacitor, 100 nanofarads. Okay. I didn't even know that you call that front end. I'm such a noob. Where's the ground? Where's the? Okay, I just take this one here. Oh, I need higher temperatures. Where are my wires? Where's my silver wire spool? Can't see that. It's gone. Foo. Then I will take a resistor leg. That will be long enough. Will it be long enough? Yes. Whatever resistor that is, it lost its complete leg now. Yeah, but you know that we want to find out what we can do. And if this could be a 20 megahertz 100 euros scope, then it's not that bad. Okay, this is the front end. Let me clip it because it's too long. And we should be able to try. We'll just use the scissors to clip it a little bit. Okay, nice. Okay. Oh, yeah. Here we go. Nope. Okay, so front end. Oh, we need to measure it. This is positive. This is ground. And we have some DIY resistors. Something missing? No. I think everything else is on the board itself. So let's measure, test our resistors. If they actually do what they should. Oh wait. Oh wait, there is like... No, I can measure between those two. Okay, yeah, I will measure it. Let's see. $18 ohms? What? Huh? Why is it 18 ohms? Oh, it might be 18 ohms because there is a loop. Wait. Yeah. That's right. Okay, I show you why it's 18 ohms. No, not flux. So, this is the circuit, and I measure between here and there, and what we get is this resistance, and this is a coil which is basically connected, and this resistance. And since we have measured like two resistors in parallel from this point to this point, we should see what we see. So this is all right, that works. Ha! Ha! Logics! Ha! Super brain move. I can turn off that stuff. Oh, you know what? I will just add $19. Yeah. That's cool, huh? We are the masterminds here. I will add a connector maybe. Oh no, that should be... I can use a 5-pin connector here. I will switch to the camera, but now you can see anything anyway, so... I will just remove a few pins from my pin header. Okay. I might just want to here to add just... Huh? Wait, that's the wrong one. Here, that one. Here or down there would be easier, and just solder it on. Oops. So I can connect this easily. Oh, maybe right-angled connector. Yeah, let's take that. Right-angled is much better. Yeah. I can use it or leave it, I don't care. Just to have it nice maybe. Here. Ah! Okay. I didn't, oh, what was that? I didn't do any length matching here. So it's not gigahertz capable. Ah. Here we go. Okay. Tippy 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 tip. Okay, let's see what we get here with our. Where's my PCB? Where's my scope? Where's my scope? Huh? Where's the PCB? I lost it. We have to end the stream. I have no clue where it is. It's gone. Oh, it's over here. In the fondue, yeah. Okay, my friends. Here we go. Again. This source, how do I leave it fix the aspect ratio of that? Can I scale filtering, blending mode, transform? Whatever. Okay. Let's see if. Okay, didn't burn. Yeah. Next to the display. It will be on top of the display. Shoot. How do we. Okay, let me connect the waveform generator. So this is minus. Plop. And this is plus. And we have some nice antennas here to receive some messages out of space. Oh! It's perfect. This is perfect. Wait, it was more perfect a second ago with no noise. What is... What? Yeah, third hand, but I don't want to crack it with the third hand. Let's do third hand here. Okay. So actually that input circuit isn't that bad with this audio transformer. Now we can contact Great Scott and do the collab, huh? I don't want to spill the beans, but this is an option. Ah, this is cool. This is cool. Okay. Yeah, that doesn't look like a viable solution. Ah, foo. Okay, I just use... Oh no. One clip is enough. Yeah, it works. Okay, I lose a little bit of... That's like 3 volts input. Oh, this is perfect. This is perfect. What? What? Peoples. Now we only need a trigger or... Ah! This is awesome. This is awesome. Okay, let me check. This is only 0.5 megahertz input frequency. Yeah, this is like 2 megahertz. Yeah, and now we get... Okay, we increase the sampling rate now. Should we try different waveforms? There is no noise. What are you talking about? Sweet. Sweet Jesus, this is so cool. This is so cool. Okay, now let's check the waveform. Oh, the square. Oh no. Oh no, the square. Oh no. Wait. Ah. Is maybe the amplitude? Oh, there is some kind of... Oh, what is that? Too much capacitance. So do you... Okay, this is a square, yeah. Okay, that's a ramp. Pause. Okay, we can change the capacitance. We can use a smaller capacitor. We can try. Okay, if that... unfortunately, it's harder to change the capacitance if we do... If we change the capacitance here, let's see what happens. Let's double the input capacitance, okay? Let's double it. Wait. Come on. I don't see a difference in... Oh yeah, that's a good idea. How about we short it? Should we short it? No. I don't think so. I don't see anything happening there. Okay, I need some cheese. I don't know about you, but I need some cheese now. We take care of that in a second. Ah. Hum. When? I don't know. In the summer. Oh, hot. Oh. Oh no, I dripped some cheese down there. 5-second rule. Okay, any ideas what to change? What happens if we increase the frequency? It's a square wave. I don't know what you mean. It's totally a square wave. How do you compensate a probe? So a bigger cap then. Do we need a bigger cap or a smaller cap? What do you say? Smaller cap? Good one. So what happens there? I don't get... So this is 0 volts. I don't get why do we have this slope here. That seems like the coil might be like discharging, or I don't know what's happening here. What is that? I know why I didn't solder on the circuit on the PCB, because oh shit, dripped again. Wow. How do you compensate a probe? Oh yeah, that's a good idea. But I don't have a trigger. The slope is high pass filtering. It's a Oh, Aaron, you're here. I didn't know even. The problem is I don't have a trigger. But I can probe it and see basically how the circuit affects the input itself. So I might be able to like see if the input side, what is? Oh, interesting. Is this, wait. Oh, come on. What is this noise? It's like, electrolytic? What? I see a slope there as well. What is this mess? Wait, acquire mode, bandwidth limiting. Yeah. Let me change. So the problem might be the driving strength of, let me check that waveform. Output settings. Output load 50. Nah, it doesn't change anything. Normal. Nah. Okay. This is basically the signal. It's perfect. I don't know why. I mean, this is like high Z now. Oh, wait. We need square. Okay. Now settings, duty cycle, offset, amplitude, frequency. No, there is nothing I can do. The only thing that we could do is like put in an actual, where's my screen grabbing? I don't see the screen. Microscope. Put in an amplifier here. What is this? Single-ended AC coupled input drive. AC coupled. That's AC coupled, but the I don't know. Hey Dave, Odessa, you want to see something? Yeah, unfortunately, this is our oscilloscope. It looks nice. Okay, let me switch the waveform. Square wave. I don't know. The wave gen really doesn't like the ramp. Okay, the similar thing. No, there is still a slope. Shoot. Frequency. Wait. 200 kilohertz is maximum at a ramp? Seriously? Yeah, what probe? There is no probe. We have connected this directly to... Do we need like a terminator or something in between maybe? Do we need a resistance? I have... What's the bandwidth of the transformer? The transformer is okay. It's from the... It's mini circuit ADT1. I paused it. That's the one. Okay, let's try again. Yeah, sine wave is more capable. Now let's just create a trigger, okay? Let's do a trigger and be done with that. Okay, you know what? We can try to add something in between, like a resistance in front of that. I mean, just put something in front of that, like 47 ohms. Okay. Oh, no, this, wait, square. Nah. It's the same. Okay, whatever. We might need some kind of compensation circuit or whatever. Yeah, 800 megahertz is a lot, isn't it? Okay, F this square wave, let's do sine and brag with that. Oh, we made it. Wait, it's so cool. Oh, no, this is so cool. Trigger. Well, this is, we need, it's bandwidth limiting already. Come on. Yeah, whatever. So cool. It's the best scope ever. Nice. Amplitude. Yeah, we can set the amplitude 3 volts. Oh, it's clipping. Look at that. Nice, huh? Yeah, let's remove that probe. Techno music. Okay, let me... I'm stunned that this circuit works like so flawlessly. I mean flawlessly, like it's working all right. And connect, I would say this is working. Last time we had just noise, and now it's also 75 ohm. Shame most scopes have 50 ohm inputs. I have no clue what you're talking about. I'm a noob. You must talk with me. You must talk with me like with a noob. I grab an energy drink here. Ah. Shall we add a clock, a proper clock? What do you think? You must talk to me like a noob. Yeah. The worst part is, yeah. To make progress in your life, you need to surround you with people that are smarter than you or more knowledgeable. But the problem is, you will feel stupid all your life. Okay, I think we are done with the cheese. Okay, cheese. Just cheese. Relatable, yeah. Oh, some hair on the floor. Now the cheese. I rub it in the carpet. Oh no. I like how there is almost no noise. Love it. Okay, let's crank it up to 11, shall we? Let's do the 100 mega samples, shall we? When you test sinusoidal signal, you can see change. Chris, elaborate on that, please. While I'm adding RPLL clock. Okay. Dip. Source 27 is input, output is 100. It's not possible. It's almost 100. a little bit higher. Dynamic static, power down, and lock enables horse here, whatever, and oh yeah, percentage. It's like 0.5 should be okay. Calculate and succeed. Yes. Okay. So we have now a new clock. Yeah. Yeah. Yeah, there is, but I can do nothing about that right now. I don't want to like tinker with the input front end, because that's like a lot of work, and we have something else on our list. Once we got everything else covered, we can optimize the front end. We have now a front end at all. We didn't have a front end. Hey, Wagon Load. Look at this. Look what you missed. We made a PCB. See that? A PCB with the ADC, and we made the front end here. This is the front end that we made right now with a transformer. And this is the signal. It looks great at 27 megahertz right now, but square wave doesn't look as nice. Yeah, this is even clipped, so the voltage is too high, input voltage. Yeah, square wave doesn't look as nice. So there is some inductance, capacitance, resistance that we need to tweak. I think I might want to get some components like trimmable capacitors, yeah, I have trimmable resistors. And then we can basically adjust it. Yeah, here's the triangular wave. So it looks like more like a shark wave. A cheap, yeah. Oh, yeah. No, unfortunately, no. The problem is I don't have the connector. Wait, I can do that. I have the connectors. So I can only recommend you go on AliExpress and buy yourself coax cables with male, female, female to female, male to male, whatever. And then all the stupid connectors that are available there. And even these here, which we can use maybe for the probe now. And yeah, this is this SMA. I think this is SMA. Yeah. So I will use that one, and we can. Yeah, but I don't have a Tektronix, whatever. We can do that another time. You send me a Tektronix front and I will use it. Okay, let's use a cheap trimmable. Where is my... Is this trimmable? Yes. Nice. Okay. Okay, I have this probe which has plenty of stuff. I can connect it here. I will connect it to times 10 times whatever. I need mail to, shoot. What is that? No, I need male to female. This is one. Then I need a screwdriver. Oh, and I need some venting here. This really stinks. No. This is stupid. It's the wrong type. This is the good type. Okay. Let's remove everything that's not needed here. This is old. Wait. What? Where did it go? Oh. Okay. So this goes away. Now we need to connect this screen. I really need that HDMI, huh? Ah, fool. Okay. So now we have a scope probe attached. The 1 kilohertz won't like help us much, I think. Demo 1. Huh? I don't see anything. What is that? Is it connected? Is it connected? It should be. Okay, let me connect it to the waveform generator. And we need a ground. Okay. Yeah. Ah, shoot. It's hard to do this with that one. Okay. The progress is great. Sion. Unfortunately, I didn't show up to Ustream yesterday, but after a long day of work, I'm really too tired and need to cuddle. No more budgie wiring, a PCB with actual feasible input here. But now this is budgie. I need to trim that. Okay, let's trim it. What do we trim here? This probe. I don't see. Okay, let me do a square wave. Let's see what we trim here. We don't trim anything. Nothing changes. Ramp as well. Oh, by the way, that's a Tektronix probe. It's not that bad. It shouldn't be that bad. But it doesn't change anything if I trim it. That's just a signal. You know what? We should use a different waveform here. Let me just probe one of the LEDs. We have LEDs here. Nah. Okay, I can see something, but this is like... What does matching mean? What does it mean? I'm stupid. I'm not knowledgeable in this. You finally made a SCARA or not? I remember when we talked about it and I told you, oh, what you need is a SCARA robot. It only moves like in that direction and then you can lower the whole arm. And now what I saw from your cover, that it's a SCARA robot as well. So that's cool. Okay, whatever. We can attach a probe or not or whatever. Scarf. Yeah, that's cool. I mean, I'm always, I don't know if it was at the end helpful. You might regret it at some point, but that's one thing that I learned in the university a long time ago. And I thought it might be the right use case. Ah, cool. I hope it works. So what are you planning to do to place with that? Do you want to like put on the boards in some machine, load the boards in the machine, or what are you using this Discover robot for? Yeah, that's good enough. Come on, let's not waste time by trimming and so on. I will read some theory on that and I will come back. No, next time we will do LEDs. Ah, oh yeah, that's even better. Then you don't even need to lower the arm. You just move it around. That's cool. Nice. Okay, let's add the clock. We get a new clock. My dudes. Clock out is CLK 100M. That will be a wire. Wire CLK 100M. Then we need a CLK 33M. That will be also a wire. Yeah, that's all right. No, I'm fine with that. Okay. Okay, what is impedance? What does it mean? Ah. Oh, okay. ChatGPT, nice. Ah, okay. So what do we do to be independent from the impedance? So the best we can do is like an op amp or what? Can I open this window? Yes. Ah, okay, nice. I will check that out. I will check that out. Thanks for the link. And now we will go to 11, crank it up to 11, my friends. Okay, so always add, oops. So pause edge CLK 100M. What is this FB? Okay, this is clock in. Input clock F. What is FB? Yeah. Yeah, that's yeah. What is this? It's an input. Let me check what. Yeah, let me check what the document says. Clock in, clock out. Huh? Oh, internal. Did I turn that on to be external? Ah, foo. Ah. Okay, I need to regenerate this. Okay. So no feedback. And now I need to rename it again. Go in RPLL. I hope it overrides this old one. I don't want the old one. Okay, here we go. Okay, nice. Huh? There is still this input. Oh, reload. Yes. Ah, here we go. Nice. Okay, no input anymore. And reload. Hehehe. Nice. Overwritten, my friends. Overwritten. No feedback. Go away. CLK in is CLK. That's our inputs, outputs. Just make it nice. That's not needed. Begin. Begin. We will do our own clock here. So CLK. Oh, if CLK. Oh, we might need 200 megahertz. Okay, let me check that. That will be 50 then. Oh. Because we do it only on the positive edge. Yeah. CLK count. Yeah. I can't read this right now. If equals oops. Yeah, that's else. That's what I think. Okay, let's add at each slope. We might need to change it because sometimes it's not that easy to do that. Yeah. There's also it's also quite hard to I mean, it's a difficult concept. Yeah, CLK 33M. Okay, let's see if we can sample at 33 megahertz. No. Oh, wait. That's a register. Ah. Yeah, no. So if we have a 100, no, we need a 200 megahertz CLK. We need a higher clock rate here. Shoot. Okay, sorry. That works better if we try 200. 5, 27. Calculate, succeed. Oh! What? Nice. That's even better, huh? Okay, cool. RPLL 200M. RPL 200M. It's nice and precise now, and I want it in my base source folder here. Okay. Yeah, whatever. Yes. Okay, 200M. Hi, Andy Mouse. Okay, so let's try with the other clock, because then we can do it like that. See, pause edge. If we do on both edges, it's harder. 200M, we don't need that. Oh yeah, 200M CLK. Okay, we don't need that feedback stuff. That should be, now we have the divider, clock divider here. What? Yeah. Oh. Yeah, that's a warning. What is that? Yeah, no worries. Yeah. Okay, whatever. $20,000 megahertz. No. Okay, I should have a 33. So the problem is, for the screen, I need 33 megahertz. And so I generated 200 megahertz clock and divided by 6. Now we have what is that? Oh, shoot. Let's do second clock then. That's yikes. Okay, F this. Let's acquire at 102 two clocks. Let's leave that clock here and do only the acquisition. But then we need to sync when to record, because this doesn't work. This doesn't work anymore. So or index, let's do it index. Color as shorter, as smaller than 800. We have 800 samples only. And then begin and add rec index whatever and index Uppsala. What is that? Did I have that here? Yeah. You missed a lot, yeah. Index +1 b1. Okay, here we go. I can be consistent with that. Okay. And then if this is 0, index equals, oops, not equal. Okay, so we do it only, we sample it once x. This is not great because this is a higher clock. This will probably lead to some errors, but we will have maybe a first. Oh yeah, index is rec 10 bits, huh? 9 0 index. Okay, here we go. Let's see. Sampling at 100 megahertz, huh? It will have errors. We need to dual clock. Let's see what we get here. So these seem to be frequency. So we have some synchronization issues between the two clocks, it seems. Is it that? Might be, huh? But we don't change it like on the... we might, no. No, we don't change it in these rows here. So we might need like a dual clock memory. Okay, let's try. Ramp only works to, okay, let's try a sine wave. Sine wave. Ups. And frequency should be higher, higher, higher. "20 megahertz is the highest it can go." What? Let's see. No, this is already some Nyquist stuff. 15 megahertz. Okay, I need to get rid of the errors. So we need a dual clock memory. Dual clock memory. So let's check memory, block memory, or we can use shadow memory. Semi-dual port mode. Let's see. No, that's only one clock. Okay, shadow memory, it's not shadow. We need dual, semi-dual port. Okay, yeah. We have, what is AD? Address, oh yeah. Address, let's say address depth 800, huh? Data width is 8. Address depth is 800, data width is 8. CLK, CLKB, reset mode. Okay, let's try the dual clock. Yeah, file name. Okay, let's leave it like that. Okay. I don't know if this is a good start here. Okay. Input clock, output, wait, clock B will be CLK. Oh, I can turn off the fondue. CLK, then we have CLK 100M will be clock A. Do we have a reset? No. Just 0. Have this 0. Address is index. Input, okay, index, this will be X. Wait, no. That's enable, write enable, read enable, C, read enable, and we need to, oh, huh? What did I do? Yeah. Address is index, and output, address B is X. Data in is, yeah, let's just ADCA. Yeah. Plus 20 minus, yeah. So this will be ADCA, data in, and data out will be ADCY, which is a wire 70Y. Okay, so this will be CLK. Okay, yeah, let's leave this. Write enable, read enable. We need this. We don't even need that anymore. We just need write enable y is equal 0 and index. Oh no. Index, yeah, is shorter than 800, which is like 10D, whatever, 800. Okay, so this is when the sample is written into memory with that clock. And now we need the out enable. Where is the out? Read enable will be, oh, we can do it here. Write enable wire and assign. This is write enable. Okay, and assign read enable will be x is shorter than 800. Okay, and oh yeah, y is 0, and that's all. Okay, let's try that. Read enable, write enable. I don't even know if that works. Okay, and then we need that here, which is ADC rec. What? No. Ah, foo. We need to replace it. Wire. What is it? 9, 0, current ADCY equals, no, assign. Oh, need a little bit shorter, and this will be, oh wait, this is ADCY. Oh yeah, but ADCY plus 240 minus 120, something like that, huh? Not plus. And this is 10D and 10D. This is Verilog. You can use Yosis to generate code, or you can. This IDE is free from Gowin, which is the manufacturer of the FPGA. So it's a free tool. You can use it to program that, and that's basically more or less Verilog or System Verilog, which is a newer flavor of Verilog with a little bit more flexibility. And now I just need to replace that here? So we are not reading from the memory, we try to get that here. Okay, my friends. The errors. Ah, yeah. Is that all? Error? Your instance name. Okay. That's like mem. Free version. I don't think Verilog is like licensed or anything, but this IDE or this, so every FPGA manufacturer needs like some sort of compiler that's like a synthesizer that generates the bytecode from Verilog, which is a simple language like C++, and basically they provide you the tools so you will be able to use their ICs. Blah, 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 blah. Oh, really? Or let's do it like that. You just, so Pete, which made this board here, Tang Nano, they have a wiki where you have everything written how to do it. It's really not that hard. You have to just register with GoWin to be able to download everything, but you can get the educational version, and this full version of the IDE is also free, but you need to apply for a license with your email address, and you will get it within 1 day. At least I got my license within 1 day. Signal connected, pin, what's one, what's... Yeah. Wait. Here. And there is basically user guide, IDE, and everything is linked. They say you need a different uploader because the JTAG they have on their board isn't like supported by GoWin. But this is like another version that you can also just download and to be able to upload. So this is what you need. And in yeah, it took me now a few months to learn everything, and still not like very. So what is this signal connected to pin CB of mem led to a no read mode block RAM? What? What is no read mode? Why? Why though? What do we have here? Let's see. What did I wrong? Okay, here. Let's do 0. Okay. There is a Linux version of that IDE. No worries. Oh. 8. Okay, I think. Oh. Huh? Clock enable. output clock enable, or what is that? Yeah. Yeah. Let's just do that. Hey, what? Sorry. This what? Oh yeah, we need 10 last current. Where's the last defined? Index. Oh yeah, we can use 8. It's all right. I just fixed the, what is this? SAP. What is this SAP again? Let me check that. SAP. What is SAP again? Let me check that. Output SAP. Yeah, whatever. Just do it. What? Or do I enable it? Okay, let's do that. Wait. Reset B. That might be wrong. It's a little bit difficult to. Where is the truncation here? Okay, 9. I just check the warnings because quite often it might be bad. Okay, let's try to upload this. It won't work. I promise you, it won't work. The hardest part that I learned, if you're using multiple clocks, you have to synchronize somehow, and this memory. What? Yeah, what is happening here? Okay, 20 megahertz. Yeah, there is an issue. So, what happens here? There is a reading. Either we don't store a value, I can't freeze it. So stupid. It might be at the wrong clock. Let's try a different edge or something. Or let's do it clock enable. Because I see like the values are doubled and then we have a 0 reading. So it seems like to be like out of sync while writing or reading the values from the ADC. So let me try something like inverting the clock of the ADC and see what happens, what happens there, okay? And I don't know where the problem might be. The problem might be caused by the delay of the logic error. Could be. No, this is the same. This is the same. Let me check if we can do just CLK here. And see if we get a bad reading there. Did you use read enable? Yeah. Oh. Oh, yeah, okay. And this is obviously wrong now. We are reading and writing at the same time. No. Okay, I don't use it properly. Let me check if I can. Something's terribly wrong. Clock. Okay, we have a read enable output clock A, clock enable B. Where's read enable? What is read enable? Where is read enable here? Let me check that. Oh, read enable is set, I think, yeah. Wait. Here, oh. The change, did I change something? Here, read enable, that's read enable. It's used. Oh. Oh. Oh, yeah, you're right. Yeah. Oh. Chip enable or clock enable B. I need to check what to use. Clock enable. Okay. Let's upload. Thanks, Max. Oh, I need some sweets or a drink. Where are my sweets? Oh no! The scope melted everything. Oh, I can't open this. This is molten now. Okay, that one isn't molten. Look at this. Oh no. Okay, let's check again. CEA. CEA. Wait. No, this is the wrong. Wait. Let me check the right one. We need SDBP. The chocolate. Yeah, that was the key side scope. Okay, and this is also a little bit molten. Marzipan and with flux core. The other stuff needs to be cooled down to solidify. Oh, that's a no clean. Is there anything else that I got? No, that's all. Only the two sweets. Oh, fool. So, now the problem is it's like a read enable, chip enable, clock enable B means we are reading. What was OCE? I get an OCD. Output clock enable or what? Ah. I'm not sure now. when do I write something and I should change the right. 55. No, that's all right. That's perfectly. So the first in the first like refresh cycle or like the screen refresh cycle, if y is 0, it will use this timing to record 800 samples. However, that takes how many samples that takes. But so we want only to display anything if we are like later. So we read only the data when y is higher than 0, because we are writing into the memory during this row. And then we will never read from, because this memory is only 800 wide and x can be higher than that because of like the sync signals that are coming later. We need also to clip it to 800 here. So that's, yeah, that's, but this is not worky. Let me try that again. Try that again. If we can make it work with 27, wait, what? No. Oh, did we? We can make it work with 27 megahertz, this memory. Okay. This is not working with this clock. So I'm wondering what's happening here. So semi-dual port in this mode design supports different read and write data widths, blah, blah, blah. Fine, also supports 3 working modes, including 2 read normal. Yeah, I know, because we didn't use this extra memory, and so the problem is now to figure out how this memory works, this IP block memory. Ah, come on, where is this stuff? As IP block memory. Shadow memory doesn't work for us. Dual port, the out. Yeah, but we had like 27 megahertz, and we need like a different rate writing and reading from the memory. Okay, let me try again without the memory block. Okay, let's try again without the memory block, but I suspect it wouldn't work. So let's do it like that. Clock in, yeah, and this is ADC rec. Yeah, but it's, Good night, Tang. Okay, you know what? I don't, it might be confusion with else. No, in if else begin. No, there is no confusion. And else. And else. Yeah, we can do that. And we can current ADC would be just ADC rec and then X, huh? Yeah, whatever. Is that? Yeah, that's 9. Okay, I'm back. Okay, at 27 megahertz. I suspect that we get just reading errors because we get, if we use a higher, oh, I'm so stupid. We give the ADCs, oh no. We give the ADC still the old clock. Oh no. Oh no. Oh no. Oh, if we want sample with that. Oh. Yeah. Okay, now it should work, huh? Oh no. This is stupid. That was... The memory worked. Yeah. That I was wondering, why do we get like 2 samples same and then an error? Hey, Dominic! Super chat! Thank you, Dominic. Okay, now now we get some interesting stuff here. Okay, what is this? What is for Lauch, for lunch, for launch? Okay, let me check that. Let me check that with the launch. ADCY, let's try that again. 100M. We don't need that. Let's try with the memory again. Okay, we're almost there. This is 600 kilohertz. Okay, this is 6 megahertz. And it looks like it's several samples, but it doesn't look like it's... Okay, let's go higher. Let's do... I don't know. No trigger. I have no trigger here. I can implement a trigger again. This is like a complete new implementation. This is a complete different software. That's 5 megahertz. This waveform. We still get glitches. I don't know where these are coming from. And it's using this block RAM. What we can do now is we can try to trigger. I don't like the glitches. How can I avoid that? I can try to get them fixed. But I'm wondering, why shouldn't it work with this implementation? Wait, I could also... Yeah, the glitches like me. Let me move that away. ADC rec. Seven. No. This is... The block RAM works better. I don't know why. Yes. But I can start sampling. Oh, I need to switch my headphone. Okay, say something. Okay, I mean the glitch, we can fix that later. I rather want to implement the trigger. Ah, yeah, here we go. Thanks. Okay. I will mark this off. So check mark for the 100 megasamples. I hope this is 100 megasamples. It looks like, at least. Yes. So let me do like almost 5 mega here. This is 4.91 megahertz. I can snapshot with my eyes. But it should be 20 samples. You can count the samples across the screen. Wait. 800 samples. Oh, that's easy. That's easy to check. We can just calculate. We have 800 samples. So 100 megahertz divided by 800. So we should get like a 125K should give us a complete screen. 125. Ah. Hundred. Yeah, that looks like a complete wave per screen, which is 100 megahertz. So we have 100 megahertz with some glitches. I don't know how to solve the glitches yet. I'm wondering if it's the read or the write. We can try that. We can check if the read or write is causing the glitches. Since we could do ADCA, that's the input. We can basically make it a constant, 120A, and that should, if we see some glitches, then it's the reading, not the writing. Otherwise, we need to do some syncing on the writing or something. I don't know. Okay, we get 100 megasamples. We could try to go higher. I don't know what. No glitches. So it's the writing, most probably. So it's the writing. You know what? Y might be assigned every pixel. Yeah, that's that line on purpose. So writing the samples, maybe we need to clock the samples because we have no clock here. Let's do that, okay? So let's get a register. rec 70. That's like maximum 255. That's like basically maximum value here. I will just use ADC buffer in our clocked thing here. So let's assign ADC buffer to, we will just buffer the input ADC A, and we will use ADC buffer to write to that. So we have like, because we have quite some distance between the ADC, and if we have wrong timings, might be when this triggers this memory write, might be too late, so we want to buffer properly in register here. Let's see if that fixes it. It should be now one clock delayed, but does it matter? No. Oh no. What is that? No. What? What is that? I think write enable clock enable A, reset A. Okay, index. You know what? Let's make this write enable, because that could like go high anytime. And let's do that in our clock here. Okay. Didn't I change it to register? Oh, still a wire here. Okay. Yeah. Push. What? Huh? Did I kill the wire or the rack now? Right. Oh, it's different. No. Okay. Nope, doesn't help. That looks like a signed unsigned problem. ADCA, ADCA, DC buffer. But still there are errors. Can't fix that. I think I need to like investigate this at some other time with some thorough. Also glitches are buffered, yeah. It doesn't help, huh? We only made it worse. Yeah, I could remove the buffer. Doesn't help. Wait, let me remove the buffer, but it looks like it's flickering on one of the samples. That might be like some kind of clock misalignment or something. I don't know. So maybe there is like some strange sync stuff. This is something I will solve off camera. Let's try. Oh no, with this glitch we will get the trigger all the time, huh? I will almost say we should end the stream for today because we got a success, somewhat of a success at least. 100 mega samples. Okay, I would really love to see that working properly. Let me try again with the clock. Let me try. Let me check. Looks like, yeah. Yeah, we could, if we have a trigger, we could do an average, but they happen all at the same time. Yeah, that's not. Look at this. The clock is relevant for that. I think our clock signal is like not good enough. We just get problems with that high sampling rate. Huh. Let me invert the clock and see if we how can we delay the timing somehow? No, that doesn't work either. You know what we could do? We can do a 600 megahertz clock and then try to get the perfect timings to sample it. No, we don't do this kind of hacking here. I think what we need to do is right now would be to try. Should we try a higher clock? Okay, look at this. Look at this. 200 M. 200 M. Oh, what errors? Oh, your instance name. Okay. RPL2. Yeah, no. You know what's happening there? that looks like a bit, like the highest significant bit is not set properly yet. That's like a transition of the highest significant bit or something. And our signals, we need like a slight delay or something to sample the input here. How did it? What is this? What is that? Index 9. Huh? The message doesn't show up yet. I heard it already, but huh? Why is the chat not up to date? Converted signed due to the fact that it's signed. Yeah. Okay. Let me. Sorry. This is funny. You got. Oh, look at this. It samples at 200 megahertz. Look at this. I'm sampling at 200 megahertz. So it actually almost works. We can overclock it somehow. Maybe if we cool it down, the IC, it will work. So I'm running it at 200 megahertz, and we can see almost samples. Now it takes one, but if we do like a slight delay, 200 is not great. We can try. Wrong button. Okay, RPLL. Okay, last thing that I try. RPLL 600M, and then we will. Well, let's do 400M, and then because this is easy to divide. 427 here, 27. Not at all. It's really cool, and I did really thermal vias and so on. So 27. Calculate. No, it's off. Is it? Yeah, it succeeded with 0.5. 200 megahertz, and that's all. Yes. Okay. Sorry, did you know that on TTS, on the Discord server, you have an Japanese accent? Reduce the amplitude of the signal. Yeah. I can do that. Yeah, we can do that, but oh, what is that? Some kind of JTAG server starting here. Okay, let me try. 400 RPL 3, and now we will do some magic. Clock. Okay, we will sample clock 100M. Let's do wire 100 not simulation. Assign sim and then circa 400 CNT, I don't know, 1 or something. And then we need that. And then we will generate a clock and try to delay it for 1. Zero and 1, which will be just shifted a little bit or something. I don't know. This is stupid, but plus 1 D1 and oh wait, CNT. Oh, 2 D2. Okay, so this is this clock 400, and now we can try that 400. Good night, Dave. I bet you didn't miss anything, or you don't miss anything today. What is implicitly declared? Okay, now we need to do it there. Count 0, 1. Yeah, whatever. Okay, I don't need that. Okay, that tries to sample at 200 megahertz. I can see that. So we will wait. Sim. Let's try that. That won't work because I see already that the clock is twice as high. We will try to shift it. Okay. This is sampling at or storing at 200, so we need counter 2, and then the sim will be 2. Okay, let's check. Can't calculate clocks. Trick. Okay. Let's check. Huh? Huh? 100 sim. Count to 400 M. Oh, stupid. This will be now sampling at 50 megahertz. Yeah, this is 50. Okay, this is 50. So let me do the sim here. It's a little bit more a little bit less glitchy, but now I can delay by sim 1 by 1 clock. That's a half clock cycle. Sim 1 and 1. Let's see. I don't know if this will cause more errors, most probably. Yeah. Sim 1. What? No. Oh yeah, that's the right thing. Okay, we need to do more here. We need to do that. Okay. Okay, this. Yeah. Sensitivity list. Yeah. Whatever. Oh, that. It's dead, Jim. What is on both edges? How do I write that? That won't. Multiple clock edges. Ah, shoot. We can't do 800. On change? Yeah. We need a higher density clock here. Okay, we can do this. Okay. Let's try this. Sim1. Oh. Yeah, we can try that. Multiple clocks is not. It's not supported. Yeah. It will always clock. We need a delay by half. No, wait. We have a 400 megahertz clock. We can't do higher than that. We can do 600. Then it will be the same as with the 200. Okay, let's draw a little bit. Okay, so what I want to do is, now we have like, this is our clock, and basically the ADC, the inputs come in like that and that, or whatever. Let me do this smaller here. And when I try to store at this, it might like some bits glitch because they're slow or whatever, too delayed. So what I wanted to do is delay my clock where the clock that I sent to the ADC should be earlier than the clock that I store at in my memory, so I can be sure that everything is like set already. So when I generate a 400 megahertz clock and only count the positive edges, I get 200. So the problem is that then when I flip at 200, I can only delay by half. And that might be too much. That's what we see. Think. No. Did it work? Wait, where is it? I want only a little bit. Where is it? Yeah, I can put in blah, blah, blah. Okay, fixed. No, that's the 50 megahertz. Yeah. No, that's 50 megahertz. No, I tried that. It doesn't support that. So this FPGA doesn't support both edges. The only thing I could do is, oh, I could delay. Let's do that. Let's do neck edge and do only one clock here. Wait, two, what? T1, and this will be CNT. And that first one starts, okay, this is the counter. The first one starts at 0 and the second at 1. We can do that, I don't care, it counts to 2. Yeah, basically. Yeah, so it's inverted. But, wait, no. They start both at 0, but one is delayed. Okay, so now we get half a clock. Ugh, I can't see anymore. It's too many. Okay, so this one is a little bit delayed. So our sim here, sim, this should be used to store, and the other one, wait, sim1 should be used to store, and the other one should be sent to, can't calculate relationship, can't calculate clocks. There's so many warnings. Okay, let's see. Oh. Yeah, sorry. Nope, that's not good. Okay, so now I try to do that one here and that one there, but I don't know how that should work. Logic, who knows? Still glitching. Maybe that's the limit, 100 megahertz. Let's try to, no, that will just flip it. Let's try different delay structure. What? Which sentence? What? New t-shirt meme? Which one? Yeah, I'm just guessing now. This is, I think it's at the limits. I should scope the bits. It seems like one bit is too delayed. Nah, that's not good anymore. Shoot. Can't do this. Limits, who knows, yeah. Okay, 100. Let's check again. Not. Maybe this not delays the clock so much that okay. Sorry, my friends, but I can't fix that right now. This is like, this glitch is... I mean, we get it almost good. I'm wondering if it's caused like by the wiring or something. There's like one significant, but it looks like the ADC, just the stage isn't finished in time. We could do a lower voltage to increase the frequency. Oh! No, we have a slope. We have a slope. And the problem is that it's not rising fast enough to reach the threshold. Okay. I'm wondering, is it 3.3 volts tolerant, or do I break it if I switch the I/O? Oh, by the way, that was a suggestion. I think we can try, or I will try to use the lower voltage for that. But let me try the level. Nah, it's still the highest significant bit. Oh, wait a minute. Wait a minute. Wait a minute. We have this thing here. What if this addition here breaks it? Okay, let's see what if we see a glitch with no, the adder takes too long. Or is this like the wait, is this the point at what we see the glitch? Nah. Okay. Now we just store the values. Now, because let's not put an ALU in between. And now let's display ADCY current is YS Y plus 128, whoops, 8D, and S blah blah blah. Okay, let's see. There is a little bit glitchy sometimes. But I see there is like there are like there are some other things happen, like smaller. Let me see that if I can sync that properly so it doesn't fool. Okay, there is a step. Okay, I call it a success, even though we get like small glitches. If we sample like this wave 125,000 times, we get a good average. Yeah, so usually the LAU might be fast enough, but we have like a chain of stuff that's happening. We're reading from the memory, we're using ALUs, and then on the right time when the clocks here for the display, it has to be ready because this is not clocked. This happens all at the same time, like that's like a huge chain of logic, including an ALU, an adder, and two adders even. And then at the end, the value must settle before this clock appears. So that this might be like a challenge to synchronize when we are reading from the memory. No, you would put a register in between, delay it by 1. We could try that. No, we could, because when we clock in, we get the results. Yeah, I don't touch it anymore. It's good enough. It's shippable. Ship it. Ship it. 100 mega samples. I call it a success. I call it a success. How do you like it? We are 5 hours in. I'm happy with the results. And that's how good. Trim it. Oh, what? How do I scale this? Yeah. Yeah, we will just average them out. This is what you have to expect at 100 mega samples. This is 100 mega samples. I prove it to you. I go high, very high, very. This is already 8 megahertz waveform, and we get still multiple samples per waveform. Here, I called it 220 megahertz. This is 20 megahertz clock frequency here. This is cool. I like it. I like it, Picasso. Here we go. This is 10 meg. This is 8, 5, whatever. We need like an encoder to scale in, zoom in, to see the values there. That's cool. I guess if we do some averaging, doesn't it look nice? That's one. Yeah, that's 1.151 megahertz signal. I see sometimes a glitch, a small glitch, glitch. But I'm really happy with the results. Okay. Thank you everyone for tuning in. Music. Cue the music. Here we go. Yeah, and we need some connectors. Yoo-hoo, it works! Pop. Sample the music. Yeah, we need to connect the microphone. Okay, thank you, Juan. Thank you, Juan. Thank you, everyone, for tuning in. It was a blast. 100 mega samples. Here you go. That might be a project. Okay, bye everyone. Thanks for tuning in. How do I turn this off? Here we go. Bye.